this because I don't like it. Yeah, why don't you just jump around here? And
why you didn't sit in the middle?
Because okay. So what we do here is we use the spectrum analyzer mode in order to pick up any kind of EMI that we got from some probes or that we get from the unit, and we don't know about the nature of that. So actually now it's the maximum span. It starts at I think at 1 megahertz or maybe some less, and it goes up to 3 gigahertz. So it's the whole band that the device actually can do. If you want to tune some certain frequency, just go to 100 megahertz and take a span of, let's say, 10 megahertz. Okay. Here you see some different peaks, and I assume those are different radio.
That's HD radio, how you're looking at.
But I don't think that we can tune in right now to have the loudspeaker, because the spectrum analyzer mode that might not work. But if you want to see what happens at that particular frequency, let's go to the marker, or maybe that one. That's 96.48 megahertz. If we tune to that frequency,
how you tune?
I need to check if it works that way. If we go marker, center marker frequency, and it puts it right in the middle.
Okay.
Now, if we go to span, if we tell 0 span, that is actually what you get, what's the level of that. And now we do have, I don't know if we can play around with the bandwidth, the video bandwidth, and the sweep time is okay, video bandwidth manual, let's go to 100 kilohertz. There's not much change. I thought I can see the modulation, but it's actually FM, so you cannot see that here.
Can you see time domain?
That is time domain. If you go to
time
span,
domain or
if
frequency
you go
domain?
to span, 0 span, that is time domain right now.
Oh, okay.
But since this is FM modulated, you will not see much, I think. I don't know, but I expected something I can't see. Okay. But with the converter you do, you might see some modulation that comes with line frequency. And that will tell you that what we have seen in the lab actually, that one half cycle you have a high level and another half cycle you have a low level. That will tell you something that actually the current path in your converter has an influence on the level of EMI that comes out. And if you search around with the sniffer probe, actually I don't know if it's good to use that mode, or if you just use a mode where the span is not 0, but let's say maybe 50 megahertz. That gives you the frequency range, and since the time in between the frequency is searched from here to here is pretty short, whatever you do in changes, if you move that antenna around, you will see right away what's the changes. Unfortunately, there's no change right now, since the radio station is all around. But we can see here, there's something jumping. I don't know where this comes from, but we can search. We can go to marker, go to the frequency where this happens. Oh, is the inverter still on?
No, of course not. Yes, it is.
It is. Maybe you pick up something from the converter. Okay. Let's go to center marker frequency and go to 0 span. Now we see some changes. And you can go to, I don't know where this is located, sweep mode I think. And you can set the sweep time. And the sweep time right now is 100 milliseconds. That is from the very left corner to the very right corner. So each division here is 10 milliseconds. And now, as you can see, if we change or if we play a little bit with the bandwidth, let's go to the resolution bandwidth and go down. There's not much you can see. If you go up, there's something you can see. So, and okay, this is a good picture. That actually tells me that something happens with line frequency. Since the distance in between the left and the right corner of each of those periods is maybe 20 milliseconds or 10 milliseconds. I can freeze, we can go in single modes, but that might take a while until I get to that. I don't know. I have to look trigger. Free run, go to extern. Yeah, now it freezes. Okay.
Can you zoom in?
I have no idea how that works. I don't think.
Can you put cursors to measure stuff?
You can go to marker and you can search around that curve. That is what you can do. And you have two markers. Go to that here and marker, select marker 2. And you can have another one. And you can go down here and you see the difference is exactly 20 milliseconds. What actually tells me there's no other device in that room than the converter, and that's the one that operates with 50 Hertz. All the other equipment does not work with 50 Hertz. That tells me it's the converter that we see. And now you see that there might be a potential to come down with the with EMI, since the different current paths make different levels of EMI. If you can find what's the reason for that, we might be able to shorten that wires or to do something in order to come down with the level of EMI at that particular frequency. The problem is if you do something, maybe you bring that level down, but it might pop up at another frequency. That is what you have to learn, but I cannot teach you anything because I have no experience with that. But you always have to check the whole frequency range if you do that. Okay. So that's it if you want to analyze something with the probes. Because the probes behave the same like the antenna, it's just local. So as you remember from the EMI lab, if you search around with the probe, you'll have different levels on the screen. And if the screen is fast, you have the chance to locate the point where the maximum of EMI happens. And that location is supposed to be the one that submits the EMI. And as you remember, if you search around the inverter stage, there is a high level of those kind of EMI. If you go to the flyback section, there's another frequency that comes up, but it's a kind of continuous. And that tells you, and that was the low frequency range where the limit line was exceeded, and this one was the one at higher frequencies. So that's the point. So you can, I cannot tell you anything how to solve the problem. I just can tell you how to locate the problem. And how it's solved, I don't know. Put some additional capacitors across the bus voltage. Try to do something with soft switching to decrease the slope for some voltage rising or whatever that will change something in that curve. And always compare the results from the antenna measurement to the measurement we did in the lab to get an idea if the level comes down at certain frequency but comes up at other frequencies, you did not a good job because you still have some violation of limit line.
Now, up the
Unfortunately,
top, you have a list of available
the
things.
measurement with that antenna does not match the measurement
Okay, you
from
probably want to rename each
the
one
test
of
lab.
them, so you're gonna have to go in.
There are multiple reasons for that. I don't know exactly.
You're gonna have to name
But
them
since this is not a shielded room, you have all kinds of reflection everywhere. You might pick up more from the signal because it's reflected than you get from the test lab. Maybe it's just the fact that all the wires go around and they make a better antenna than you do in the test lab. I don't know the reason for that. But the only thing you can do is you can do the measurement. If there's no change in between unit turned on and unit turned off, you're fine. You can't do anything with the test receiver anymore. But if you know that at certain frequencies you have a problem, you can search with the sniffer probes and look where it is. And from my experience, I know that if you get some results from the test lab, exactly at the same frequencies, you will find something with the sniffer probes. And if you're able to bring down the level with the sniffer probes, then you might solve the problem in the test lab. That's the way you can do it.
Okay.
How does it say cut?